Hey everybody, what we're going to do here is go over electron configuration. And what this is, electron configuration tells you what orbitals the electrons reside in an atom. So it basically tells you how many electrons there are and then where they sit in the atom. So let's go over electron configuration. If you remember correctly, we did a periodic table in class that looks something like this, where you labeled your s orbitals, your p orbitals, d orbital, and f orbital. If you use that during this video to help you, that would help tremendously when I'm mentioning the s orbital or the p orbital, and to give you an idea of your location on the periodic table. The first problem I want to do is let's do the electron configuration for phosphorus. If you look at phosphorus, it is located, it's the 15th element on the periodic table, and it's located right over here in the p block, in the p orbital. So what we're going to do is look where it is. It is in the 3p3 spot. So remember, we got to go down just like the atom would be filling in its electrons as it goes. We got to start with the Aufbau principle, and the Aufbau principle is we fill the atom from the lowest energy levels all the way to the highest energy levels until we run out of electrons. And then we'll also bring in Hund's rule and Pauli's exclusion principle in the next section. Okay, but for the Aufbau principle right now, we're going to start off in the lowest orbital, which is 1s, and we have 2 electrons in the 1s. And we're going to fill both of them because remember, we're dealing with phosphorus, which contains 15 electrons. So we're going to make it through the 1s, and since there's 2 spots for those atoms to go, electrons to go, we're going to fill both of them, so it's 1s2. Then you look down at your periodic table, and you'll get to the 2s. Now remember, these numbers in the front represent the energy level, and it's the row or period of the periodic table you're in. So you're dealing with the 1s, which is the first energy level, the s orbital, and there are 2 electrons in that orbital. We get to the 2s, and we're going to fill up that one as well. Because so far, if you look at your superscripts, you can add them up. That is how many electrons you have used so far. So we've used 2 electrons in the 1s orbital, 2 electrons in the 2s orbital, then we get over to the p orbital in the second period. So the second energy level, p orbital, and we have a total of 15 electrons. So far we've used 2, 4, and the p orbital can hold up to 6 electrons. So we'll have enough to fill it. So we'll get all the way through it, and that'll be 2p6. Then we have enough left over to make it back down to the third energy level. So we'll be at 3s orbital in the third energy level, because remember, it's just like Microsoft Word. You're going to go across from left to right, then you're going to come down and go left to right again, and you just fill in the energy levels as you go in the orbitals. So 1s2, 2s2, 2p6, we're at 3s, and you're going to fill both of them, so that's going to be the 3s2. And then so far you have 2, 4, 10, 12, dealing with the subscripts, you have 12 electrons filled in so far. So you make it to the 3p orbital. You have 3 electrons left. So you'll make it over, if you look on your periodic table, you'll make it over to the p. 1, 2, 3. That's 3p3. So you're at the third energy level, p orbital, and you went 3 over. So phosphorus is located at 3p3. And these are the electron orbitals you filled up in order to get there. So this is the electron configuration: 1s2, 2s2, 2p6, 3s2, 3p3 for phosphorus. Okay, next up, we're going to do cobalt. Okay, the electron configuration for cobalt. First, find cobalt on your periodic table. It is element number 27, CO. So here we go. We have 27 electrons to fill in. So we know we're going to make it through a lot of the S's and P's. So let's go down to, let's see. I got my periodic table now. So we're going to start at the first orbital, which is 1s, and work our way across and work our way down. So with 27 electrons, we know we're going to fill in the 1s, which is 2, The 2s, it has 2. The 2p, and it has 6. 3s, it has 2. 3p, and this time we have more than 15 electrons like phosphorus. So we're going to keep going past phosphorus and fill in the 3p orbital, which makes 3p6. Then we're going to drop down to the 4th energy level, and you arrive at 4s. Well, we have so far 18 electrons filled in, and we have 27 in cobalt, so we know we'll have enough to get through the 4s orbital because there's only 2 electrons there. So that's 4s2. Then the next orbital is the 3d. Now remember, the energy level drops back down for the d's. They're always one less than the energy level you're on the periodic table. If you look at the row of the periodic table, you're in the 4th row, which is the 4th energy level. But that d orbital is part of the 3rd energy level, so you always drop back a number when you get to the d orbitals. So 3d is where cobalt resides, and it's the 7th element in. So if you count across on your periodic table, you'll wind up at 3d7 for cobalt. And just to check your work, you know you have 27 electrons in cobalt. You can count your superscripts. So 2, 4, 10, 12, 18, 20, 27, and cobalt is number 27. So you figure, good sanity check, you're probably right. Okay, last example we'll do is an ion. We'll do magnesium 2+. Sometimes you'll see it 2+, +2. It means the same thing. I've seen it written both ways, so I don't mind whatever way you write it. So if you have Mg +2 or 2+, that means it has a +2 charge on it. We know from earlier chapters that magnesium as an ion with a +2 charge means it has lost 2 electrons. It has 2 more protons than electrons. And remember, you never, ever lose protons because then you change the element altogether. So you're dealing with an element that has lost 2 electrons. So it has a 2+ charge, and magnesium is element number 12 on your periodic table. So if you lose 2 electrons, it drops back down to 10 electrons, and that takes on the configuration of neon. So look where neon's located. It's at the 2p6 spot. So we'll fill in every energy or every orbital up until the 2p6. And that includes the 1s2, 2s2, and 2p6. And magnesium has 12 electrons normally, but with a 2+ charge, that means it has 10 electrons. So let's count over here. 2, 4, plus 6 is 10. So we know we probably got that right. That's a good sanity check to count your superscripts to make sure it equals the number of electrons in that atom or ion. All right, now as you can tell, we're going from electron configuration to orbital diagram. I'm going to use the same elements. That way you can see it in both manners. That way you have the electron configuration for it already done. Now let's look at the orbital notation for it. We know the electron configuration from the previous example was 1s2, 2s2, 2p6, 3s2, 3p3. So we have that written out. We already have those orbitals in place. Now, we're going to show you how to fill those orbitals. And we did this in class together, so this shouldn't be the first time you're seeing it. So see if this will jog your memory. Remember, when you're filling the orbitals, you had 1s2. So that means you had 2 electrons in that orbital. So when you fill the electrons, we're going to put one arrow up and one arrow down. And remember what that represents. That represents this electron having an up spin and this one having a down spin, so they can kind of tolerate each other in the same orbital, because remember, they're both negatively charged, so this helps them to not repel each other as much. So that's also called Pauli's exclusion principle. Remember, you cannot have 2 electrons in the same orbital with the same quantum state. This quantum state is upspin, this quantum state is downspin. So now you go to the 2s orbital, we fill that up. You have the 2s2, which is 1 up, 1 down. Then you get over to 2p, where there's more than one orbital, more than one shell in this orbital. So we have to use Hund's rule, which is no shell gets more than 1 electron before anybody gets. Let me say that again. No little orbital gets 2 electrons before everybody gets 1. So they share. Everybody gets 1 before anybody gets 2. So as you do this, if you're filling the 2p orbital, which we know we had 2p6 for phosphorus, we're going to put 1 up, 1 up, and 1 up. Rather than go up, down, up, down, up, down, we make sure everybody gets 1 before anybody gets 2. And with an orbital like this, the 2p6, which we knew everybody was going to get 2, it doesn't matter as much. But when you're running out at the end, when we get to our 3p orbital, that's when it'll make a big deal. So we get over to 3s, we know it's 3s2, so 1 up, 1 down. And now our final electron configuration for phosphorus ended at 3p3. This is where it matters. 3p3 means we only have 3 electrons to fill, but you have 6 spots available, 2 in each orbital. So if I put 1 up, 1 down, 1 up, that would not work because you're breaking Hund's rule. Hund's rule is everybody must at least get 1 electron before anyone gets 2. So what happens is you must go 1 up, 1 up, 1 up, and you see how no orbital has 2 electrons. Everybody has at least 1 before anyone gets 2. So that is the orbital diagram for phosphorus. Okay, now our next orbital diagram, we'll do it for cobalt. Now for cobalt, we had the 1s orbital. Tell you what. Okay, I'm a magician. It all just appeared now. The beauty of videos, right? All right. So now I have each orbital written out for cobalt. Cobalt goes all the way to the 3d7 electron configuration. So I know I'm going to have to go all the way down to the 3d orbital to fill this in. Knowing that, I can just go ahead and everything prior to that I had to fill in because we've got to follow Aufbau principle. Go to the lowest energy levels up to the highest energy levels. So I can just go up, down, up, down, up, 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 down, down, down. 3s is up, down. 3p is up, 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 down, down, down. Get down to 4s, it's up, down. And here's where I'll run out. I'm going to end up running out at 3d7. That'll be 27 electrons. So the way this works is just like we did for phosphorus in the first one. We ran out of the 3p orbital. Everybody gets 1 before anybody gets 2. So we're going to go up, 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 up. That's 5 electrons. And then we're going down, down. After you fill in, everybody gets 1. If you have any left over, you come back and start at the beginning and start going down with them. You start the downspin, and the first 2 get it, the last 3 don't, and that's 3d7 because there are 2, 4, 5, 6, 7 electrons in the 3d orbital. So that is the orbital diagram for cobalt. All right, and the final one we're dealing with for orbital diagram is going to be magnesium with a 2+ charge. And we already said the electron configuration was going to be 1s2, 2s2, 2p6. So this one's easy because it fills the 2p all the way up. So we got 10 electrons in this orbital diagram. So we got 2 here, 4, 5, 6, 7, 8, 9, 10. Just remember, no matter how many electrons you have, you're just going to fill in the the orbital diagram with an up electron first, then a down electron. Especially when you're in the 1s or 2s, only 2 electrons can go in there, so you just go straight up, down. But in the 2p or anything beyond the p's, like the d's or the f's, you just need to verify that everybody gets at least 1 before anybody gets a second. So that'll fill in the 2p orbital. So magnesium with a 2+ charge has the same orbital diagram as a neon noble gas. It has 10 electrons. And that's it for electron configuration and orbital diagram. Good luck on your test.